All right. Are we live? Okay. We're at the home stretch. So in a little bit, we'll be, half hour or so we'll be done. When we've done this, there's this echo. I keep hearing this echo. Oh, okay. When we do this, when we started doing this, we get requests at the end to say, okay, well, it's very nice to tell us about resumes and interviewing and how to do networking and all that, but what are the jobs? What are the jobs? Where are the jobs? What's happening? So we've put together some material. It's not necessarily 100% of everything that's going on, but give you some idea of areas where technology is trending and what's viewed as a hot area. So I'm going to talk about future technology directions. IEEE has a group called the New Technology Directions Committee, and they have published some information about what the IEEE's technical societies view as emerging areas. We're going to talk about the energy workforce, health IT, smart grid, critical infrastructure protection, and cybersecurity. So the New Technology Directions Committee, there's links here, and that was started by the Technical Activities Board, and it was to identify opportunities to engage the engineering community and the public, and focus on emerging technologies through various activities inside of IEEE. So it was designed, there was always a thing, people were saying, IEEE really aren't tracking the new technologies in the societies, we need to be more responsive, so that's an attempt to do that. So there's a bunch of working groups, biometrics, displays, organic electronics, RFID, smart grid, and then there's a website, a portal on the web to get to the information. So biometrics, I don't know, I'm not going to go through and belabor all these definitions, but it's personal recognition, it's fingerprints, it's face scanning. This picked up a lot of interest after 9/11. You know, how can you pick people out in a crowd to identify the bad people from the good people? So there's a lot of R&D going on in there. I think at this point it's maybe not as emerging as it was because it's probably emerged some. Display technologies. What's going on there is people want to have wearable displays that look like paper. More are human factors, and so there's research going on in there and displays. A biggie, all of us aging baby boomers, distributed diagnosis in home health care. How can we keep people in their homes? There is a telehealth, distributed diagnostics. Can you have home-based devices that'll do periodic testing of people and send the results back to the doctor? There is a interchange protocol, HL7, for electronic data exchange in this area. So that's being developed. So if you're into communications, this is a growing area. Learning about HL7 may not be a bad thing. Earth observations is another big area. Ground, airborne, or space-based observations. Remote sensing. Look at all of the interest after Hurricane Katrina and tracking hurricanes. This summer, the interest in tracking the oil spill, where is it going? All of that. There's a lot of interest in these kinds of being able to do these kinds of observations. Electronic health records. The Medicare has a requirement for electronic health records by 2015. How many people you go into the doctor's office and they have racks and racks of paper file folders? Nothing's on the computer. It's all in paper. If you want to go see a specialist, they got to make a copy of this paper file and send it over to the specialist. Why couldn't that be electronic? That would be a lot. We could do a lot more that way. So that's the idea in that. And then when you get into that, there's a lot of other issues around that, like security, access, things like that. Electronics recycling. There is now a European Union, the Waste Electrical Electronic Equipment Directive. So anything that you produce that's got electronic components in it that may have materials that you really don't want to get into, like the water system or something like that, they all have to have a disposal process. For manufacturers provide a disposal process for the equipment when it's end of use.
Ed,
Yeah.
I was just walking in and you talked about European Union, again, globalization.
Right. So there are requirements from the European Union that any manufacturer that wants to ship into there has to meet. So there's all sorts of different regulatory issues. EP is an interesting thing. That's an IEEE standard for environmental performance, basically green computers. It mainly applies to the government, but that's becoming more prevalent. There's a new development, I believe, recently. Where is it here? These power bricks. I'm out of camera, but these I can't hold this up. These power bricks. Where's one? Everybody knows what these are. These things. How can you make these more efficient? How do you got your TV and you turn it in its instant on mode while it's sucking down power? And there's a lot of power, so that people are looking at standards requiring, different kinds of power supplies now and all these electronics. So there's a lot of that stuff going on. Future power, fuel cells, batteries, solar, wind, all of this. There's a lot of interest in that, a lot of money being put into that. LED lighting. There's a directive to replace all the incandescent bulbs with LEDs.
And Ed, don't forget, the smart grid.
Right.
Big topic right now.
Right. I have a whole section on the smart grid. But you're right, the smart grid. Organic electronics, electronic paper. How can we make it that way? Plug-in hybrid electric vehicles. So you've got the vehicle, and you got to plug it in. Well, how you going to get the 220 volt outlets with 40 amps in the garages or in the parking lots or wherever they're going to be? There's a lot of money. I was reading the other day. There's a company, I think in California somewhere, they got $120 million from the contract from the government to put charging stations in parking garages. So there's a lot of work going on there. Portable information devices. Oops, that's not a portable information device. That's the microphone. You got your PDAs, your Blackberries, your iPads. All of that is just sweeping through industry and portable wearable technology. So all of that area, RFID is another area. I thought RFID was about inventory control, but actually RFID is a way to do remote sensing, low power sensing. You can take an RFID and you can stick it in your shipment of lettuce and have it wake up every so often and take the temperature. So when the shipment arrives, you can read out and you can say, well, gee, was the lettuce at 40 degrees the whole trip, or did it spend 3 days at 85 degrees because they turned off the refrigeration to save money, and they turned it back on again to deliver the lettuce to me, and I've got a whole shipment of spoiled lettuce here, and you can reject it. So there's all sorts of work going on in RFID. And last but not least, smart grid. Part of this idea with these plug-in hybrid vehicles is everybody comes home at night, or a sufficient number of people come home at night and they want to plug these all in. It's like plugging in a whole bunch of water heaters into the system all of a sudden, at a time at which everybody maybe wants to be cooking their dinner or whatever, and you're going to overload the grid because the grid isn't designed to deliver this amount of power continuously. So how are you going to handle that? So there's a lot of R&D going on in that. The other thing is that we have this issue with the baby boomer people going to be retiring sometime between now and 10 years from now. Utility workforce, half of the utility workforce that work for the power companies is over age 45. This also applies to academia, it applies to the defense industry, A lot of places. So that doesn't do us people who are baby boomers any good, but it means if you can hang on for another few years, there's going to be a shortage of labor. There's an issue here. Only 26% of high school graduates are considered qualified for STEM education because they're not taking the subjects in high school to give them the background to go study that. So who's going to replace all these people who are retiring? So that's an issue that's coming up, and that's going to have an impact on the workforce. Renewable energy workforce. Ethanol is not as big in favor anymore since gasoline isn't $4 a gallon, at least everywhere. But if you look at the amount of renewable capacity that people are legislating, there's a tremendous demand there. I won't go through this. This is a different jobs, type of renewable technology and the different kinds of categories of jobs that are required. And there's people working on workforce development. The Power and Energy Society has an energy workforce collaborative where they're trying to figure out how they can address getting people trained to work in these industries. Global energy. This is from, I think, Leonard Bond, Region 6 Director. If the population grows to 9 billion and everybody wants to have a Western-style lifestyle, you could have an energy demand increased by a factor of 6 or 7. So how are you going to generate all that power? If people are worried about greenhouse gases, how are you going to do that with generating lots and lots of greenhouse gases? So do you have to use nuclear? Well, people don't want nuclear, but what are the options going to be? So there's going to be there's a lot of areas where there's a lot of change and things happening where they're going to need people who can work on that. I think we talked about this. The Stimulus Act, like it or not, whatever, did provide and specify health IT. And so they've just got $19 billion to invest in developing healthcare IT. And $7.2 billion for expansion of broadband service so you can get all these medical records and these x-rays and all this imaging data sent around efficiently. What does this mean? There is in Health and Human Services, there's now an Office of the National Coordinator for Health IT. They're working on standards development, information exchange, grants to states, regional resource centers. So here you've got a thing, only 25% of the healthcare providers have electronic medical record capability. So 75% of the healthcare providers are going to have to implement this stuff in the next 5 years. I can go back, what does the slide say? It doesn't say when. Okay. But Medicare, I think it was, 2013. So you got small clinics, they don't have any IT staff. So who's going to help them out? Who's going to become their IT people? They can outsource to some large corporation or some small business started by some IEEE member looking to become an entrepreneur. What about home health care? How are you going to hook that up? Before 2015, they're thinking 50 to 200,000 new jobs in this area. Consultants and trainers. So you understand the technology, you explain the technology to the doctor, okay? And this is just terminology, I won't read through all of this, define what this is, but here's the vision. To have this national health information network and have all of these communications linking all these things together, linking where do we want to start here? Patient, hospitals, insurers, home health care, prescriptions, clinics, all to be linked together. And then this would be nationwide. So you'd have all of these regional networks around the U.S. What are the skills? Have some familiar with healthcare, knowledge of the standards, interoperability standards. Privacy and security is going to be a big issue. How do you keep the hackers from hacking into your medical records? Right now there's medical identity theft where they get your social security number, which is used by your healthcare provider, and then they can go off and file claims pretending they're you. Broadband technology is going to require a lot of implementation of broadband into a lot of places. Smart grid. What we have here is we have a growth in demand, we have a cap on the generation, and eventually we're going to run into a limitation. So what they're looking at is demand side management. Requires integrated communications, sensing and measurement, determines all sorts of advanced research, control methods, algorithms. How you're gonna instrument, basically you're instrumenting everybody's house. So they can figure out dynamically now what's going on with the power consumption. So if they have to, but instead of doing a brownout, they can tell half the air conditioners on the left side of the street to shut off for 10 minutes. And then they can tell them that you can turn back on, we'll shut the air conditioners on the right side of the street off, potentially, something like that. Or you can say your water heater, you have shut off all the water heaters because we don't need to have hot water right now because we need the power for something else. Now there's all sorts of issues on this, all sorts of policy issues, but the idea is you can control demand. You control demand, you bring down the big expensive peak where they have to buy all this expensive generation from gas turbines, and eventually they can, and you've got more power that you can spread around for more people to use, so you don't have to build more power plants. So that's the idea. Can we make the grid smarter than it is now? I won't go through all this, but this is an example of different kinds of end appliances, lighting, pool spa. They have smart meters. This is what Pacific Gas and Electric is installing smart meters. This is from last year. We had a presentation by one of their director of innovation. It's interesting. So we had a Region 6, we had a central area meeting, and they had a bunch of students. They invited a guest speaker who was the director of innovation for Pacific Gas and Electric. And I found it very interesting where he had worked before he went to Pacific Gas and Electric. Anybody have a care to hazard any guesses? He worked at Intel. I thought that was very interesting that people are leaving Intel to go to the power industry. So, and he was doing stuff with wireless there. So they're putting in this smart grid. They're having a proprietary IPv6 network that's not on the internet to hook all their smart meters together. And I forgot, you can't read this all, but their smart meters together have 40 terabytes of distributed memory and 100 million MIPS of distributed computing power and all these meters, but they got like millions of meters. So it's a large investment that's going on in smart grid. I won't go through this. Key thing is the standards. Utilities want standards because they want to be able to plug and play. They don't want to be locked into a Cisco or a IBM or some proprietary solution. They want to be able to mix and match. What else? These are all the standards that are being worked on in different organizations. Little alphabet soup. In here is IEEE, Zigbee, which is based on an IEEE standard, and a bunch of other groups. And then here's some more standards. There's a group called the UCA, which is in charge, Utility Communication Architecture Group. That's an umbrella organization managing all the standards development. So there's an IEC standard. There's a thing called the Open Smart Grid. So there's these things that you could get into. I won't read through this. Critical infrastructure protection. Here's another interesting area. You've got power plants. You've got SCADA controls. Anybody hear of the Stuxnet malware in the news? So they designed customized malware to attack a specific control system, and they believe it was in Iran. So it could wait, and then it would, at a certain right thing happened in time, it would take the system down. So that put the fear of hacking in a lot of people. Because if they can do it there, can they do it at Progress Energy? Can they do it, at Bonneville Power or someplace like that? So critical infrastructure protection is a big issue. I won't go through all the history. There was a presidential directive in 1998 that defined 17 sectors, chemical, power, communication. Some of them are IEEE sectors. There's been some, another more Homeland Security directives from the President and some action in the Senate. There was a bill in 2007 for chemical safety. IEEE, here's the 17 sectors, IEEE, energy, IT, communications. So part of what has to happen here is how do you know if a company's critical infrastructure protection is up to snuff? Well, somebody's got to go out and check that, test that. They've got to audit them. They've got to assess that. So there's a big emerging market for people to do those kinds of assessments. Risk management. We mentioned that a little bit earlier. Rules and standards to make sure that the threat has been reduced or the threat has been mitigated. So what are the kinds of things that people do here? The cybersecurity, which is your traditional IT kind of security thing. There's SIP assessment, audits, risk assessments. So there's all sorts of different things that need to be done here. This is not typical engineering. This is more a judgment and experience kind of job. You would need to know how to lead a project, planning, organizing, communicating, writing up results, interviewing people, analyzing, and things like that. However, it's very useful for people to have sector-specific knowledge, domain knowledge, and then you couple that with some auditing knowledge. This is still an emerging field. In the power industry, it's getting more and more defined over time. So if you're going to be an auditor, you need about governance, risk, and compliance, GRC. I think we talked about the risk management, process management, about quality, these different kinds of issues. And the interesting thing here is you're dealing with reasonable assurance. Can you conclude with reasonable assurance that they've met the thing? You can't do an absolute. It's not like designing computers where you got a 1 and a 0. I think we talked about that. Cybersecurity. There was an interesting book published this spring by Richard Clark called Cyber War. Has anybody heard of that or read it? It's quite an interesting thing. And part of what he was talking about in there is exactly the kind of thing we saw with that Stuxnet malware. That people can develop targeted things to take down stuff. So what's happening here is in Florida, there is a national initiative for cybersecurity education, and there are grants available for programs for retaining people who worked on the NASA program for cybersecurity jobs. Oh, yeah, and there's been a need identified by the federal government. They need 30,000 cybersecurity personnel. So there's a big need. DHS and the Air Force have authority to hire 1,700 people over the next 2 years. So this cybersecurity thing is, there's this institute, I think it's in this, I'm not sure which city it's in, but it's in this area, this greater area here. There's a website. NIST is working, National Institute of Standards and Technology is working to set them up. NIST is defining the standards for the federal government on what cybersecurity means. So they've set up this thing called the Global Institute for Cybersecurity and Research, if you're interested in that. So that is a whirlwind tour of some areas of potential emerging jobs and job needs. Let's see, how am I doing on time? I'm march right ahead. I'm getting the continue to march ahead thing. So let me, I want to bring up the last slide. How do I do that? So we're going to do the wrap up. And then wrap up. Okay, great. Okay. All right, so we have, if your brain is full, raise your hand. The bits are, the information is falling out of your ears, right? This is that kind of a workshop. So we don't expect that you're going to walk out of here with all your question answered and you got your 10-year career plan all done. There's going to be some homework, okay? That was part of that packet that I pointed out this morning with the 6-page list of exercises culled from the slide sets. You've got your self-assessment to do. Look at your skills. There's some examples in there. You can go online on the web and look up self-assessment. There's lots of resources and things you can read. I think there's things in IEEE USA. Does everybody here know about Today's Engineer? Today'sEngineer.org. That's a publication from IEEE USA. They have a very extensive career archive in there with a lot of articles written by people on interviewing, resumes, negotiating, goes on and on and on. Elizabeth Lyons, who's a resource member of our committee, has written, I don't know, 10 or 12 articles, I think, by now on things like that. There's a lot of good stuff in today'sengineer.org. So the other thing is you have to, for your resume, we have what's called value-added resumes, value-added interviewing, value-added job search. I was reading something on the web today, and that's actually, they're calling it value-added now. So you need to look at your accomplishments. You need to look at your work history, identify what your skills are. So if you're going to do a career transition, that kind of thing. You need to position yourself. What do you want to do? Do you want to get some work? Do you need work? Do you want a job? Do you think you want to be a consultant? You know, what's your focus going to be? Things like that. You need to figure out how do you want to, you know, what are you going to do about doing that? Do you need to update your skills? Do you need some training? You've identified some stuff you want to do, but, you know, hey, this is a great, interesting job, interesting work I want to go after, but I really don't know quite about this, so I need some training. So identify some training, look at, you know, follow, subscribe to some newsletters, read some blogs, look on the internet, whatever you can do. Then you need to develop your network and your brand, your elevator pitch. You know, how are you going to do that? So you work on that, target your companies, pick an industry, pick some companies, go out, do the creative job search, do some informational interviewing, find out what do the employers want, what's the market like, make some connections, and go for it. And then as a result, if you get some good prospects, develop your targeted resume, and good luck. So that is it. We fill in the evaluations. Vin reminds me again. So we really want to see these. So with that, we are done, I believe. Going once.
I want to highlight, it doesn't stop today. You've got Region 3 and IEEE behind you. Those URLs, if you haven't done the survey, please do. We need more data. And those other 2 addresses, keep checking those on a weekly basis. We're finding more stuff, we're answering questions, and if you don't go there, you won't benefit from it.
Right.
Thanks.
And also, if you're IEEE guys, go find your section and say, okay, where's our PACE chair? Where's our follow-up classes?
And our employment coordinator.
And your employment coordinator, so that you can work on your self-assessment, have an evening meeting, look at these things, and work on them together. So thank you very much. Oh.